Okay, so let us see now the expression when they are giving us. Still we are seeing on theta above the horizontal. A stone is thrown at an initial speed of this from our horizontal cliff, and the stone hits the sea at a point level, the base of the cliff. So if this is our cliff, it's going to hit it there at a point level. This is the base of the cliff. Now this stone will be thrown, it's going to come like this, and then it will hit at the sea at the level of the base of the cliff. I think that's what they mean. At the point level with the base of the sea at a distance of 72 meters from it. So now mean that they are giving us this from here up here. They are giving us this is 72 meters like that. So from it, from the cliff, it hits the sea from there. Then let's find the time for which the stone is in air. And simple terms, the one that makes this where it's in the air. Then they ask us to get the height of the cliff, maximum height reached by the stone from the sea, and so on. Now, if they give you the listing in terms of I and J, in simple terms, they are giving you the horizontal and then the vertical component. So what you do to this you resolve it upwards and also horizontally. So our UX here is the I, which is 24 meters per second. Then this one is the J, which is our UY, equal to 10 meters per second. I said, but the moment they give you to the IJ, that's the basic you have to use there. So now after getting that, now they're asking that's the time for the 5 minutes. By the time this particle is covering this, it would have covered this distance. So meaning we need to get this time. So meaning from there, from S equal to UT plus a half AT squared, if my U, X is going to be ST, but we say the moment we are dealing with the horizontal distance, horizontal, this always acceleration is going to be 0. So my Sx, which is 72, because this is the distance you can see from here, this is the distance I need to cover. So 72 is equal to Ux, which is 24, then T, and from here, my T is going to be 72 divided by 24, which gives me 3 seconds. So this will give me 3 seconds. So meaning the time, because to cover this distance, it will be the time it's going to be in the air. As simple as that. So this is our part A. Okay, now in part B, they are asking us to get height of the cliff. Now they want us to get this height here. Now, remember, this height, when the particle moves from here up to here, it would have covered only that. So meaning, in our part B, I'm going to say my SQ UT plus a half AT squared. Now here we are going to deal with horizontal, the vertical distance. So let me call this height H. Let me call that height H. So meaning, but so this one now is below the point of projection. So meaning I'm going to take it as a negative. So our SY will be equal to UYT. Now it's here because it's going against gravity, we are going to be adding a half D. Our F is going to be negative D, then T squared. But remember, to cover this height, it would have covered the whole of this distance. So now it means this is the height we want. It's going to be negative because it's below. So we have now negative H equal to our UI, which is 10 into our time, the time to cover this distance from here up to here. Remember, from here up to here, it is the displacement. So because it's going and coming back at the same point, so there is the displacement is 0. Now covering this is going to be the height. So mean the time between from here up to here is the same time used to cover that distance. So this will be 3 minus a half 9.8 into 3 the whole square. And negative H there. It's going to be here I'm getting negative 14.1, and so my H is going to be 14.1 So that's it. Then maximum height, which by the story from the sea. So in simple terms, the maximum height, first of all, we need to get this height first. This height here, which I'm going to call L. So meaning now the whole height from here up here, let me call it up there, it's going to be L plus H, the whole of that height. From the sea, remember this is the sea, so I need to get this height which is H, then this height here, the maximum. So that is my L. So now, you know, and so now in part C, from V squared equal to U squared plus 2AS. Now the height, here I'm looking for the maximum height because I'm going vertically upward. So I mean, Vy squared will be equal to U squared Y, then minus 2DS. Now, my S there, you see my S is going to be L. From there, my S is L. Put in here, but you know at maximum height, orange, our Vy is 0. Here they are in 0 equal to this of Y, which is 10 squared, then minus 2 into 9.8, then L. So it's that now my L from there is going to be 100 divided by, this is going to be 19.6. I'm getting 5.102 meters. So meaning that now the whole of that height from the sea, height from C is going to be L plus H, which is then plus H, which is 14.1, and this is going to be, and they add there again 19.202 meters. That will be the height. Now from here up there. The rest of it, which the stone hits the ground. Now to get the velocity, part B, our velocity we need the Vx and the Vy. This velocity is given by Vx, then Vy. So how can we get this? Our Vx, remember, our Vx is equal to orange Ux. So our Vx is going to be now 24 meters per second using U plus 80, because in horizontal direction acceleration is going to be 0. So Vx Ux, that's why you get like that. Then our Vy will be equal to Uy minus Dt. So our Vy will be equal to Uy, which is 10, then minus 9.8 into 3. So our Vy is going to be negative 19.4 meters per second. It shows us that in the result that was positive. Of course, the moment you see that you are having such diagram or is a displacement, but can it's going to be that. Now, we said you can give this velocity in a vector form. If you give it in a vector form, then you don't need to get the angle of the direction. So now our V here will be equal to Vx, which is 24, then negative 19.4. The moment you give it like this, you'll be now adding 24I, then minus 19.4 J meters per second. If you give it this is the nav, because you have given it in a vector form, which has direction, and also you can easily get the arm. Or you can get to be equal to V squared X, V squared Y, and also our alpha, which is Vy over Vx. So either you do this or this, but I think this is better. because you see you are giving it in a vector form. So if they ask for velocity, you can give it in a vector form like that. So that's it. Let us see more examples. See the next lesson.